Hi class, and welcome to our video lesson on the second day of 7-4. Right now in today's lesson we're going to use trigonometry to find side lengths. So to do that we're going to be using our calculator quite frequently today, and we're just going to practice really quick putting these 6 into our calculator to find the sine of 30 degrees. Very simple. You just press sine in your calculator, the sine of 30 degrees, close the parentheses, and then enter. And so it is 0.5. If you get something different than 0.5, your calculator is in radian mode instead of degree mode. If you have a calculator like mine, you're going to press the mode button right next to the second. So then you see this menu that pops up, and right here you see this radian and degree part right here. As you can see, mine is in degree mode. Yours would be in radian mode if you got something different than 0.5. So you would have to change it to degree. And the way you do that is you just highlight it and then you press enter. Okay? So, again, you could practice this for the other ones. I'll do one more with you, but then you guys can do the rest of them on your own. We can do the cosine of 46 degrees. So in your calculator, you press cosine 46, close the parentheses, enter, 46, and that decimal is 0.6947. 0.6947 if we round to 4 decimal places. 0.69, I guess this one rounded to 3. I prefer 4 decimal places. 0.6947. So you guys can put the rest of these in your calculator, pause the video and try that, but after you should get these. So please pause the video before I reveal these and try those on your own. Okay? All right. So again, the trig ratios, the sine is equal to opposite over hypotenuse, the cosine equals adjacent over hypotenuse, and the tangent equals opposite over adjacent. That's where we get the SOHCAHTOA from. So S-O-H, S-O-H, ka, C-A-H, and TOA, T-O-A. So we're going to use these trig ratios to solve problems. So we're going to do this one in class all together. So we're first going to start off with this one. I want to find the length of this segment. So what I'm going to do here, class, is everything revolves around the angle that we're talking about. I'm going to circle 34 here for a second so you guys can see what angle I'm talking about. And now I'm just going to label all of the sides of the triangle, such as this side is the opposite side, this one is the hypotenuse side, and X is the adjacent side. So I am not given anything about this side, so I'm not even going to look at that. So I'm going to look at the trig function that uses the hypotenuse and the adjacent. So as far as sine equals opposite over hypotenuse, the cosine equals adjacent over hypotenuse, and the tangent equals opposite over adjacent, which trig function uses the adjacent side and the hypotenuse side? The adjacent side and the hypotenuse side is the cosine trig function. We're not going to use this one, we're not going to use this one. So now that I know that I'm going to use the cosine of the angle that we're talking about, the angle that we're talking about is 34. So the cosine of 34 degrees is equal to the ratio of the adjacent side, that's X, divided by the hypotenuse, and that number is 27. Yeah, 27. Okay, so that's how we set up our proportion. So what we're going to do here is now we're going to cross multiply. It's the cosine of 34 over 1. So when we cross multiply this, we're going to get our answer. So X equals the cosine of 34 times 27. So here's how you do that in your calculator. The cosine of 34, close the parentheses, times 27. And that length of X is approximately to the nearest tenth, 22.4. X equals 22.4. Okay? Notice how the next one is slightly different, but along the same lines. Again, I'm going to circle the angle that I'm talking about, and now I'm going to put everything in relationship to that angle. So here's the opposite side. This one is the hypotenuse side because it's opposite the 90, and here then by default is my adjacent side. So I'm actually going to use the same trig function again, aren't I? I have the adjacent side and I have the hypotenuse. I'm not given anything about opposite. So the cosine is equal to adjacent over hypotenuse. So I'm going to say the cosine of the angle that I'm talking about, 23 is the angle. The cosine of 23, that equals the adjacent side, 18, divided by the hypotenuse, which is x. Okay? So now here's where this one is a little bit different than my last one. When I put this over 1 and I cross multiply, notice how I get the cosine of 23 times x. I'm going to make this a lot simpler for you. Just pay very close attention to what I'm going to do here. Previously, we talked about how like 2/3 is the same fraction as 6/9. And remember how I was able to move this down here and this up here, and I was still able to make an equivalent fraction or a ratio, a proportion. Because 9/3 is the same fraction as 6/2. So it's legal to change around the extremes or to change around the means in a proportion. So what I'm going to do to make this easier to solve is cosine of 23, I'm going to move you down here, and x, I'm going to move you up here. Now it's going to be a lot easier to solve, because now I get x equals 18 divided by the cosine of 23. And now I could put that into my calculator and I'll get x all by itself. 18 divided by the cosine of 23. So we do 18 divided by cosine 23, close the parentheses, and that length of x is approximately 19.6. 19.6. X equals 19.6. I think it's good to use some mental math here too as well, class. Notice how x is the hypotenuse. It's the longest side of the triangle, so it had better be longer than 18. And sure enough it is. 19.6 is longer than 18. On my first problem, I found x right here. Well, that was not the hypotenuse, so my number had better be less than 27. 27 has to be the longest. Notice 22.4. That seems logical. Let's try this third one here. What trig function am I going to use this time? Well, if 32 is the angle I'm talking about, this is opposite, and this one is hypotenuse. Here is adjacent. And so if I want to find x, I got to say what trig function uses the opposite side and the hypotenuse side. Well, opposite and hypotenuse, that's the sine, isn't it? The sine equals opposite over hypotenuse. So the sine of what angle? 32 degrees. That equals the opposite side, which is 30 over the hypotenuse side of x. All right, class, when we cross multiply, we get stuck, don't we? We don't want to cross multiply that. Just like the last one, instead, let's move this down here and let's move this up here. So x equals 30 divided by the sine of 32. You guys can put that in your calculator. When you do, you should get approximately 56.6. X equals 56.6. Few more left. These ones might seem complicated at first, but the more times you practice them, the better you get at them. Here we go. 38, this one is opposite. 34 is adjacent because my hypotenuse is opposite my 90. So which trig function uses opposite and adjacent? Of course, that's the tangent, isn't it? Tangent equals opposite over adjacent. It's the TOA, T-O-A. All right, so the tangent of what angle? 38 degrees. That equals the opposite side, which is x, over my adjacent side, which is 34. You don't have to change your means and extremes around on this one. You just simply cross multiply these two. And bangarang, you get the answer. X equals the tangent of 38 times 34. So tangent of 38 times 34, you should get 26.6. X equals 26.6. Why don't you guys pause the video and try the last two on your own, please. Here's what you should have done. You should have gotten opposite and adjacent, which is the tangent. So the tangent of 21 equals opposite over adjacent. And then hopefully you saw that if you tried to cross multiply these, you'd get stuck. So instead of cross multiplying them, that's where you change this to move into the denominator and change this into the numerator. You're changing around your extremes. So x equals 16 divided by the tangent of 21. And you did that in your calculator. You did 16 divided by the tangent of 21, and you got 41.7. X equals 41.7. And then you did this one on your own, and you did awesome. I know you did, because you used the sine function, because you have the opposite and the hypotenuse. So of course the sine of 25 is what you wrote. That equals opposite over hypotenuse, x over 10. You cross multiplied these, and you had so much fun doing it too. You multiplied that by 10. And so when you took sine of 25 times 10, you got 4.2. And it was so much fun, wasn't it, everybody? It's amazing how these trigonometric ratios work. I hope you had success with this video. Let me know if you have any questions when you get to class tomorrow.